we're going to do a measurement here. We measured with the ohm meter just a bit ago that's about 69 ohms. I could set this switch box, R sub A, the adjustable resistor, to 69, and then it would balance theoretically right at 50, but I set it at 70. That's close enough. We're just in the ballpark of the middle of the wire here, which is where it's most accurate. So let's check this out. Here's my probe. It's working, set at about 2 volts. And if I put it at 70 or 80, touch there, you see it jumps a couple notches, a couple microamps to the left. If I put it over here at 30 or so, it jumps 1 or 2 notches, microamps, to the right. And so let's try 50. That shows me, first of all, that the meter's working and that I'm okay by not overdriving the meter in this situation. So let me just put it at 50. And as expected, we see nothing happening because the balance is really close to 50 where this Wheatstone bridge is most accurate. So it's time to switch the plug to the G0 position, which means there's no built-in resistance there, and this becomes actually very much more sensitive, not twice more sensitive, not even 10 times more sensitive, but many times more sensitive, 20, 30, 50 times more sensitive. So we have to be careful where we put this probe. I'm pretty sure that 50 is pretty close to the right answer, so let me go back and put this on 50, and you see it actually 50 is not quite the right answer because it moves about a microamp and a half to the left, and so let me move this above 50 and it gets worse, so that means I got to go below 50. So let me try 49. Okay, 49 is pretty close. Now, what I'm watching on that meter is not so much, is it exactly 0, but does the meter move at all? If the meter moves at all, it's not at the balance point. So if the balance point, if the pointer there is not set at perfectly 0, at least from your perspective, it doesn't matter. It just matters that the pointer doesn't move at all. So let me poke around here until I get the place where the meter doesn't move at all. Okay, so it's right there. With it connected or not connected to the slide wire, it reads the same. Not quite 0 from my perspective, but it's close. So I'm looking down here, and you can read this probably to the nearest millimeter only, so go ahead and read it to the nearest millimeter. Let's not get that fussy. So it's 48.8 on the slide wire. So that's the balance with my R sub A adjustable resistor set at 70. It kind of makes sense because where this is on the slide wire, this resistor is proportional to this length, and this resistor is proportional to this length. If that's 69 ohms and that's 70 ohms, it's going to balance a little bit below 50, which it did. The calculated resistance for this resistor with the adjustable resistor box set at 70 turned out to be 66.7 ohms. So since I know it's a little bit less than advertised and less than 70, I went ahead and set this resistance box at 67 ohms, which should balance it really, really close to 50. So let's see that. We want to try this 2 or 3 times, make 2 or 3 of these quick proportional calculations to get values of R sub X and average those values to get a maximum deviation from the true answer, which is we're going to assume is the average. So I haven't changed that very much. I don't have to go back to the G1 position. I know 50 is going to be real close to the answer, so let me check 50. Okay, again, to make sure it's working, I can move a little away from 50 so it's working. And again, I want to balance this so the needle doesn't move, not necessarily that's at 0, but it doesn't move. I think I found that. So I'm not surprised that the probe is at 50.1 centimeters. So it's almost exactly balanced in the middle, which means since that it's set at 67, if I do the calculations, I'm going to get an answer that's just a little bit, actually a little bit higher than 67, because we're past the 50 centimeter marker. So this resistor is a little more than 67 ohms, and so it's not quite the same answer. It's probably, if I go the calculation and do this again, it's probably going to be like 67.1 ohms. So it's only 4/10 of an ohm different from my last time. And again, take another third reading and zero in on this and get an average and the maximum deviation. Let's say it comes out 67.0 plus or minus 0.3 ohms. That will be my answer. I'm just making those numbers up, but that's something like what you'll get. So this is what we want to do for all the resistors. The single resistors, first of all, so we can really get a good value to the nearest tenth of an ohm for each resistor R1, R2, and R3, and then put them in parallel series and parallel combinations, and then grand total series and parallel combination. You should be able to, using the formulas, equation 2 and equation 3, and the proportion that we've been using, that's the balance condition for the Wheatstone bridge, to get the answer based on the best values for R1 and R2 and R3, and compare those to the value you get by balancing the bridge with those different combinations as explained in the second part of the lab.